Okay, in this problem, we want to see if f is conservative. If so, we're going to find its potential function. So what's the formula? We're going to take dq dx. There you go. dq dx. So let's do that first. And we want to see if that equals dp dy. So dq dx, these are partial derivatives. Make sure you use a funky d. Okay, which one's q? dq d, it needs to grow a tail. dq dx needs to devolve. That's q, right? So what's the derivative of q with respect to x? The derivative of q with respect to x. It's linear, so it should be a constant, right? 3. There we go. Now, does that equal the derivative of p with respect to y? Yeah, so I'll just state it. It does. So what does that tell you? It's conservative. Therefore, f is conservative. So we want to find its potential function. That shouldn't be too hard. There's only 2 components, right? So what does it mean to say f is conservative? It means there exists, let's use a fancy, more advanced mathematical term. You know what this backwards e means? There exists, yeah. There exists a function f such that st what? Del f equals uppercase f. That's what it means to say f is conservative, right? So how do we then label, instead of calling the components of f, p, and q, what's an alternate way to label them? Little f sub x, and p is little f sub x, and q is little f sub y. Which means if we take partial integrals, we don't really call them that, but if we integrate with respect to x, if we integrate f sub x or p with respect to x, we should be able to recover some version of the potential function, right? So that's the idea here. So f of x, y should equal the antiderivative of 5x plus 3y. And we have to do it with respect to x, though, right? So dx. Would you buy that? So if we, and that again is supposed to be an x, but my x's are coming out looking like y's today. So let me try again. There we go. So we integrate with respect to x. What do we get?
5 halves x squared plus 3y.
Okay.
Some function.
So 5 halves x squared plus 3, I'll go xy, plus what?
Some function of y.
Some function of y. What do you want to call it? Not f, right? G. Okay. So g of y. That's our constant, right? With respect to x. Does everybody buy that? So that's, I mean, that's not complete, but there's your first attempt, at least, at finding the potential function. So the problem is we don't know what g of y is, right? So what do? Take the derivative with respect to y, and then we could set it equal to this guy, right? So that's the plan. Then, so we're going to take the derivative of this guy with respect to y. I'm going to leave off the of xy notation. What do we get?
3y plus 2y.
Wait a minute. So we're taking the derivative of this guy with respect to y. What's going to be left when the smoke settles? 3x. 3x plus, it is a single g prime of y, right? Which is okay to use since it's a single function of y, presumably. And then we set it equal to the f sub y from the vector field, right? The j component, in other words. So we get that's equal to 3x plus 5y. And then what goes away?
3x.
Subtract 3x from both sides, and you get a nice g prime of y is equal to 5y. And then what do you do to both sides to get to remember, we need g of y, not g prime of y, right? So integrate. Integrate. If you want to make it sound exciting, say integrate. Don't do that. Don't do that. Please don't do that. I can imagine you on the test, everybody saying integrate over and over again, because there's going to be a lot of integral. No. Oh, and then I really should notationally be correct and put in a dy there. Okay, so you integrate that, and what do you get? 5 halves y squared plus a true constant c, right? So how would you rewrite this thing? f of xy then we'll take to be 5/2 x squared plus 3xy plus 5/2 y squared. Now, and then plus c. Is there any way you can check your answer? Just take the partials with respect to x and then make sure it matches up with p, right? Take the partial with respect to y, make sure it matches up with q. Then you know you're right, if it does.